Thank you. Good morning. My name is Jakub Nabrdalik. I was already introduced, and I'm a very boring person. So actually, this is everything you need to know. In case you want to search for some more information, I have a web page, and I have a LinkedIn profile. And besides that, I'm boring. The company I work for is a little bit more interesting because it's Allegro. Everybody knows what it is. It's a small shop in Poland, and it's got 10,000 servers, 600 engineers or more. About 550 microservices on Mesos, and we have no idea how many microservices outside of Mesos because nobody can count them. We got about 13,500 requests per second, which isn't much if you compare us to large international companies, but if you consider that this is a Polish company or basically operates only in Poland, then it's not that bad. And we got about 200 million visits per month. We make about 90 deployments per day to production and more to actually test in the dev environment, but that's quite easy if you have so many microservices. And we work in Java, Groovy, Scala, Kotlin, Go, and basically every single language except for the .NET platform. And we work on Spring as a default. And we kind of have like libraries on top of that. So that's about the company. And so now you know what's the basis of this situation that I'm going to explain, because what I'm going to talk about today is modularity, basically. This gentleman died last year, actually. And anybody knows who he is? Oh, just a few people. Basically, he was a brilliant engineer and a brilliant writer. He wrote many books, and he was a very good writer with that. And if I can suggest something from this presentation other than the topic of this presentation, read his Protocol of Dying, because you are going to die, and he described very well how to do it. Okay? So you might as well know how to do it well. And he's the author of ZeroMQ, and he's the author of a lot of very low-level stuff. And while working on this low-level things, which are quite complex and complicated, he said something like this: the physics of software is not algorithms, data structures, languages, and abstractions. These are just tools we make, use, throw away. The real physics of software is the physics of people, specifically our limitation when it comes to complexity. So the science of programming is not about the languages and tools. It is about making building blocks that people can understand easily. And that's about it. So what kind of building blocks do we have, especially in Java? So we all know how to deal with large building blocks, like, for example, more than a few thousand lines of code. We make jars, we make modules, and if you are lucky to have microservices, you can work with microservices as well. Below that, and below a few hundred lines, this is also very simple. Why? Well, because we got private methods and nested classes. And while nested classes might not be so popular, private methods, everybody knows them from the university, school, whatever, right? But then there is one problem that I can observe while I do a lot of consulting and programming. What happens, what's the building block between a few hundred and a few thousand lines of code? Most developers actually either do not care or do not know. But there is a thing called package scope composition. And this will be the base of the talk. So how do people use package scope? Can you see that? This is a package called Java Util. Everybody knows what Java Util is. And here you can see IntelliJ IDEA has got this little padlock. And this little padlock is sometimes open, and sometimes you have just a dot. When this padlock is open, it means that the class is public, right? And when there is a dot, it means that the class is package scoped. So if you look at something like Java Util, then you see that most of those classes actually are public, okay? But that probably makes sense because this is a library. This is the basic of the language, actually. And, well, most of this stuff is supposed to be used by developers, right? But then, when you look at a similar package, but from a different company, from Google, then you will see that what you get here is that most of those classes, and we are looking at Google Common Collect, right? Most of those classes actually are package scope, and just a few of them are public, okay? Now, so is the package scope really useful in Java? And if you look at the source of all knowledge for programmers, Stack Exchange, Stack Overflow, then you will find answer that, well, yeah, you can deal with that, sure, but to be honest, other than the aspect of the design purity, you can make everything public and be okay with that. And it seems that that's what most people actually think of it. And if you look, and why does it happen? Why does it look like this, right? Well, if you look at any tutorials or any examples, most of them, like this one, this is a pet clinic version 2 from the last year, look like this. Have a look at the package composition here. We got the model, repository, service, util, and web. Who had a chance actually to have their package layered like that? Yeah, most of us did, right? So if you have something like this, there's no other way to than actually make everything public. You can't just do anything else, because all the interactions are going to be between those packages, or most of them, okay? Now, why? Why did we do that? I have no idea, but it was quite popular, and actually we all did it, right? If you look at other examples, and most of the samples look like this, but you could argue that maybe, well, this application was actually to show different tools or different aspects of Spring framework and how to use different layers, right? So it makes sense that it is layered like this. What if we take another example? And again, I'm going to use an example from Spring Framework, the most popular framework in Java, right? And you'll see something like this. This is a greenhouse. This is an application that open source sample that actually comes from 2012. And you can see here there is a lot more packages there, right? And the question is, what is the reason behind those packages? Why do you think? What was the decision that the authors made? What do you think? I've asked this question several times, okay? Because in this sample, you can actually have stuff package scoped, and nobody could give me an answer. Why those packages and not the others? Because you can see here something like account, something like, for example, home, groups. Maybe these things are about functions, right, that the system has. But then you see something like database and connect, and it looks like infrastructure, right? So it's kind of hard to tell. What was the reason for the packaging like this? And if you look inside, actually, what you can see is that even though you could have something different, all the classes, as usual, are actually public, okay? Now, there was this little statistics there made over 3 million GitHub accounts about different keywords and what are the most popular keywords in different languages. And it's kind of hard to find how popular the package scope in Java is, because that's the default and we have no keyword for that. But what do you think about public and private? Which one should be more popular? Who thinks it's private? Okay, who thinks it's public? Half here, half there, right? Have a look at this. Public is the third most popular word in Java, right? And private is far behind. And I don't have the statistics there, but I think the package scope is actually further away. So it's even worse. Now, how does it work in other languages? Why does it look like this in Java? How does it look in other languages? Let's have a look at Kotlin, for example. In Kotlin, you have public as a default. So you don't have to put public. Everything is public by default, right? Then you have private, protected, which works similar to Java. And then you have internal. And internal is pretty interesting because it's not exactly package scope. It says that this actually class or a method cannot be seen outside of the building scope, which is like a Maven Gradle project or IntelliJ IDEA project if anybody does build with IntelliJ. So that's what Kotlin has. And Kotlin is quite a new language, right? So they completely said, okay, we're not going to use package scope because nobody understands what it is. Then how about Groovy? Groovy is a bit older, I think. And it also has got this public as the default, right? So everything you make is public by default. Then you got private, protected. And then you have package scope. But it's quite strange because it's actually an annotation. Well, it turns out that it is an annotation because it's not actually a keyword, and it reverts the default behavior in Groovy to the same as in Java. And they've made it only in the version 1.8 because the Groovy has this assumption that it should be, well, you should be able to use it everywhere you use Java, and it should behave more or less the same. So they had a case issue where they actually had to have a package scope. For what reason, I have no idea. But it's an add-on to the language, right? And if you look at the most powerful, probably the most powerful language out there, Scala, then you will see that Scala has got some similarities there. Public is default, okay? So no special keyword is needed there. But then you have protected and private only. However, this time you can mark for which classes or packages this class is protected or this class is private. So basically you can mark, you have a very strong mechanism to actually mark which classes and which packages can use this package or class or a method. So as you see, pretty much everyone said that let's forget about the package scope and let's make the default public, right? And that's because most of the developers actually think this way. The package scope looks like somebody forgot to add something. Now, I will try to convince you today that actually making packages and using packages and the package scope makes the software much easier to maintain. Now, what would be if the package scope was a default in Java and we would use it as a default? Here you have an example. And in this example, oh, sorry. Too fast. In this example, what you can see, what you can tell me right away. In case it's not visible, here it is. Huh? Exactly. You see the entry point for the package. You see that this package has just one single class which is public, right? What does it mean? It means that you can ignore everything else because you cannot touch it. And if you want to use the package or a feature of this package, you should look at this, right? So it's pretty simple. And actually, there are many more advantages. So first of all, you know where the entry point is. Then you have less to put inside your head. Why? Because if every single package looks like this and has got just one single public class or not too many public classes, then you can ignore the majority of the code because you know they cannot be touched, okay? Then it's easier to test. Why is it easier to test? You can focus on the public class if you want and ignore the rest. Basically, you don't have to have unit tests for every single class. Unit tests, as the name suggests, is testing a unit. And here, the unit is the whole package, okay? Then it's easier to refactor, move away, or throw away. Why? Because we know that as long as we do not touch this single class, which is the facade here, we will not break anything else. So we can refactor as much as we want. And it's a simple block. The whole package, which is quite complex, there's a lot of classes there, right, is a simple block from the perspective of other packages because it's got just a single point of entrance, just a single facade. And this is actually the production code. So well, you know what? This is the default in Java, which is kind of surprising. Perhaps this is how the Java was designed to be used, so that you will make packages like this. Now, to explain it a little bit further, I would like to show you the answer for the question, on Stack Overflow. What's the difference between default, public, protected, and private in Java? And the answer that is the most interesting, and I think it was the accepted one, was actually from a Perl programmer who says that he understands this topic very well just because he is a Perl programmer, okay? So that makes sense. And he explains that there are actually 4 different scope modifiers there. And then he says something like this. Okay, and there is one more. This one more is called published. And it means visible outside of the code you control, okay? It's not part of the Java syntax, which is a problem in itself, but we really need that keyword. We could really use that keyword, okay? That this is your API from now on, and older parts of the code can use this code. And then he discusses what to use in practice, because we don't have the word publish, right? And he says, okay, stick to the private and public and forget about everything else. He forgets completely about the package scope as well. And that's it. And you know what? Public means published. If you make a class or a method public, this is your API that other developers will consume, other classes will consume, other modules will consume, okay? So actually, this is how the public is supposed to be used, but that's not what it happens. So I would like to show you a simple example of how actually you can develop this and what more benefits actually from using the package scope as a default. Let's say that we have to write some software. And this is the stuff that the client asked for. And I work in Allegro on actually the content, so like articles, which I'm sure you were not aware Allegro actually has articles. But the CMS is pretty much everywhere in every company. And the client asks for something about articles. So he wants to create articles, delete articles, preview, publish, reject, and so on. And then, because we have a UI, and of course we have to show everything, we got several methods that he wants. He wants to search by ID and other stuff, like. So what happens is the simplest possible solution to that problem, of course, is to using Spring, for example, is to have something like this. The user sends a post to create an article. You got a controller. Let's say we're using you're programming the way I do, so I have a package and I have a module for articles. I have a facade. You call create article DTO. We validate the information. We send it to the factory or creator or builder, depends how you call it. Then we save it, and then you return some information back, for example. So these are the classes that we're going to have, and this is very common in a Spring application. Which of those classes have to be public? Any guesses? Huh? All of them. Somebody said all of them. None of them. Not a single of those classes needs to be public. Why? Well, Spring calls the controller, and that's it. But Spring doesn't care about us using public or package scope. So the question is actually which should be public. And then I've heard the answer there that the facade should be public because we may need to call the same functionality from other modules, right? Other features. And that makes sense. Besides that, we will also have DTOs, data transfer objects, just because Java doesn't have data structures, right? And we want to send some information. So there will be 2 more classes that will be public, and this will be, for example, create article DTO and article query DTO to be able to send data back and forth, right? And the controller actually does not have to be public and probably should not be public for the simple reason that you will never call a controller from your code, most likely, okay? And that's it. So what happens is that the package, after a while, looks like this, and this is the real implementation there. we have some classes here, and here the controllers are called endpoints because, I don't know, but just because. And then you have some validator. All this is package scope, and then you have the package domain, where you have the package, you have the class article facade, which is public, and nothing else, okay? And this describes all the use cases that you can have with this package. And inside of this package, you also have two sub-packages, DTO and exceptions. Because if you think about it, exceptions are also the kind of information that goes back from the facade. So actually, if you want to handle those exceptions, they need to be public as well. Okay, so that was nice. How about the query? How about the search? Because it's all cool when we want to create some behavior, but then we have to get the data out, right, to show on the UI. And there are many different requirements there as well. So what happens is, for example, you probably heard that yesterday. I'm using CQRS, and CQRS is Command Query Responsibility Segregation, which means that you basically have two different paths for two different types of users. One is coming through the facade, and what happens here is that the flow goes like this. If you want to change something inside the domain, you call this guy, oops, and that's again too fast. And then what happens is that he calls the domain, all the action is being taken. But if you want to just query for the data, you hit the database as fast as possible, and basically you don't want to use anything else. And you can complicate this thing. You can have two different databases. You can use event stores and event sourcing if you want to. But I want to show you how simple it is actually. So let's say you start with an entity. And I'm using MongoDB, so my entities are actually documents, and it's because it's a document store. And this is a class called article, okay? And for the article, when I want to get the data out, I have another class called article query DTO. And here you can see that the article actually works on a collection, which, if you don't know MongoDB, is the same, more or less the same as a table in SQL store. It works on the collection Mongo collections articles. And this one works on the same exact collection. But here, I can only map data that I want to show, and I have no way of actually persisting this class because I have a different repository for it. And that's all I need to have CQRS. So how does the query part looks like, for example? Well, the query part looks very simple. You have the DTO, which has got to be public because this is the information that we return. We have the repository, which is another entry point to the module where you can get the data, but you cannot do anything with this data apart from showing it. And then you have, for example, some search params because you need it to actually pass what kind of a search you're performing, right? And if you do not use MongoDB, the other solutions are also so simple. Because, for example, what happens here is you have JPQL, which is working on a SQL data store. So any SQL database you want. And you can select directly into a new object. Here, for example, the publisher is actually being loaded and put into publisher info class, right? Or you can use Spring Data Projections. There's a bazillion ways of doing this in a very simple manner to have the CQRS. And what about next package? The next package that I have is a bio package. And this one also looks the same way. It's got a simple facade. It's a very simple package. And it's got a query part. And if you want to know what function it provides, then you look at the API, which is the facade. And that's it. How about some infrastructure? If you're using a domain-driven design, then you know that the most popular way to actually deal with the infrastructure is to put an interface inside your domain and then implement the infrastructure connections somewhere else. So in my package, and I have another package called category, which deals with the category tree from Allegro. Here you have a public interface, which is part of the domain, but there is no implementation. The implementation comes in a different package, and what you can see here is that this time I do not have a public class at all. There's not a single public class. How is it possible? Well, it's very simple. What happens is that this package is has got the implementation of category tree client, and there is the class category client configuration here, okay, which configures this for Spring. So Spring will, in the runtime, of course, replace the interface, or actually inject the implementation of the interface there, but I don't have to have anything public. Now, it's pretty simple to deal with something that isn't public at all, the package that doesn't have anything public, okay? And the configuration classes from Spring, of course, do not need to be public because you do not call them too often, right? And then it brings me to another problem that I see quite a lot when I see people using Spring, which is to use auto-wired and component on every single class, which what it means is that you are using IOC container and you're putting every single implementation of every single object inside the container. The question is, why? You've just made every single class accessible. It's the same thing as making it public, right? So what should happen is that you should think about what should be public and what should not. And here you can see my configuration for the article facade, which you have seen before. And what happens here? Well, I've got the method that creates the facade, okay? This is the last part. And it's got a lot of dependencies because this is the facade, it's the entry point. But most of those classes I can actually create by hand using new. And all I need from the Spring is the stuff that works on the I/O, okay? These are the external dependencies, you could say. So you got article repository, reader client, which is just the client to another service, article factory for some reason, and some properties because they also come from a disk or a config server or whatever. And nothing of these has got to be public or registered in the IOC container, okay? Now, why would I have the I/O classes or things that use I/O as a parameters there? Any ideas? Why would I have article repository here as a parameter? Why don't I create the article repository myself, except for the reason that the Spring Data can do it for me and can do it much better than I can do? Huh? You can inject it for test, but that's actually not the reason. Well, you see, I want to have this method inside the article configuration class because I can call it inside the test, of course, and get a fully functional domain, or in other words, my module, which is article module, and it will be ready, and all the dependencies there will be created here. But because I'm using test-driven development, I want my test to go fast. So whenever I'm using a unit test for a whole module, I want to not touch the I/O, okay? And this architecture is pretty old. This is called ports and adapters, or hexagonal architecture. It's got several names. And Alistair Coburn actually, I think, was the first one to name it this way. And the way it works is that you have your whole application except for the things that work on the I/O. And this application, or this module, can be tested in unit tests in milliseconds if you just fake or give some dependencies, or the adapters here, right, to work on something in memory. So how does it, why am I so furious about it? Why do I want it so much? Well, actually, there was some research. Jakub Nielsen in 1993 actually found out that if you make the user wait for something less than a second, then he will still have the flow. He will not notice the behavior, okay? So what it means is that if I fire my test and it's less than a second, then I can fire my test all the time. I can have it running in the background, basically. If something takes more than 10 seconds, then it loses user attention. So I'm using Facebook then, or I'm on Twitter, or whatever else. But basically, it just lost my attention. And it works for developers as well as for users, right? And then there was a very interesting example years ago, I think it was by Sabre, that if their experience showed that if tests would take more than 30 seconds, developers would stop actually running them. And the interesting part is that I actually teach test-driven development and behavior-driven development a lot, and I meet a lot of people that actually tried to do test-driven development and behavior-driven development, and they said, no, it doesn't work for us. It's bullshit. It takes too much time. Look at their setup, and what I can see is that their tests run more than 10 seconds. Sometimes they work in minutes, right? And if I were to do test-driven development with firing tests in minutes, I would go nuts. I would never do it. So I actually teach them how to set up the tests properly so that they can run under a second and have the feedback under a second, and then they can do test-driven development. It's easy. And why is it important? It's also important because a brand new, empty, in Spring 4, I think, yeah, that was a test performed on Spring 4. If I just create a new application on Start Spring IO, and I want to run it on my MacBook Pro, and I want to run only the tests, what happens is that the Spring is going to start, right? And it takes 7 seconds for empty Spring on my laptop, which is quite old, okay, to start. So actually, 7 seconds, I got 3 more seconds, and I'm on Facebook. And I cannot work like this. Now, in a real application, it's even worse, because my application, when I run integration tests, and I'm still using H2 and basically in-memory databases and everything, and mocks, it takes 22 seconds to actually start. So I'm actually way past going to the internet. I'm now on a coffee, right? So you cannot have tests running like this. And I want to give you another example why it's so easy to actually behave this way if you just use package scope correctly. Let's say that you have to implement a new application. And let's say that our application is actually about renting movies, because why not? And what do? The first step is to gather requirements, right? There is no magic product owner who will bring all the requirements. You have to do it yourself. So you get the requirements and you write them down, and they look like this and like that. And you don't have to read it. But basically, there's a lot of stuff going on. There, we need to rent a movie. We need to be able to return the movie. We need to be able to calculate some kind of a bonus points, and so on, so on. The price, for example. So what's the next step when you develop an application? We got the requirements. What's the next step? Come on, you're all software engineers, right? This is what you do for a living. What do you do next? Start coding, exactly. You can start coding. As Tomasz Nurkiewicz once said, 15 minutes of planning can save you a week of coding, right? The same 1 week of code, actually he said 1 week of coding can save you 15 minutes of planning. So how about doing some planning? Because before we can actually do anything with planning, we need to turn these requirements, which look like just pure text, into something called a happy path, right? So this is a testing scenario or specification, and this we can turn directly into a test. And this is a Spock test for it, except it's all empty. I just have all the labels there, so you know what we want to achieve. And then we can do the planning, which is architecture, actually, right? And how you do the architecture is a bit more complex topic, but basically you can split the application into different modules, right? And I'm not going into the details. You can use event storming for that. You can use many different ways. For example, the oldest way of finding the nouns and the verbs in the requirements. Or you can just use your head and find something else. And I would, for example, I have designed here several modules: film, rental, bonus, and user. And I have this thing called infrastructure, which I don't know if this is a module, but actually I have to have some infrastructure because I'm going to use a database and so on. So what happens next? We have to validate that. How do we validate an architecture? That's another topic which is very interesting for software engineering. But just to simplify this, you can draw a picture. And if you have a picture and you have two rules. First rule is things should not talk too much with each other. And the second rule is whenever you will have a new requirement, you should have changes only in one place. And if you can like assume those two things, your architecture is not that bad already. So we have some modules here. And we'll focus on the films module. It's very simple because this is just a catalog of film. You can get details, list films, and get the details of the film as well here. So what's next? Next, we need, using test-driven development, we need to actually test it. So we start with a unit test because, well, I don't know if this is all correct, if this is a good assumption, if this is a good model for my problem, right? So it's much easier to actually start with a unit test than integration test there. So in my unit test, I need to somehow test my module. And my module is called film module, right? This is this module. So what happens? I need to have some kind of an entrance. So I will have a film facade, and I already know that I need some point of entrance. And how do I get that facade? Well, I can just create it by new, but that's not enough, because actually, this is going to be a whole module. So this will be a lot of classes. So instead of creating new, I will use the creator pattern, and I will use in Spring, it's usually a class called configuration. So I will have film configuration. Please give me film facade and a wholly configured module, okay? Next, I will create two films, and then I will test it. And tests are simple like this, right? I have discovered that I need to add something to be able to show something. Then I have another test, which is just a test that if I add several films, that I will get them. And this is testing all without database or HTTP, okay? So how does it work? How can I add something to our module and then take it back? Well, as you can see, these are all the classes inside the module. And you can see here, there is in-memory film repository, right? Because you need to be able to access the database, but the database doesn't have to be an external dependency. It doesn't have to be somewhere on file, on disk. And how hard it is actually to implement a database in memory. This is how hard. Basically, you need one data structure. It's a hash map. And if you get very fancy, you can have concurrent hash map. And that's it, right? Why? Because, well, this is going to blow up if we put too much data in it because, well, no memory is limited. But that doesn't matter in our tests. And basically, it doesn't matter in an application unless we actually have a lot of data there. So we can use the concurrent hash map and implement save, find one, delete, find all, and that's it. Very simple code. Everybody can write it, right? So now that I have all those classes and a database in memory, I can verify whether my assumptions and the ideas about the module are correct. And I have tests in milliseconds. Writing down all of that takes just a bunch of, I don't know, perhaps half an hour, just a few minutes probably, right? And then what happens next? If we verify, okay, this is probably how the catalog is going to look like, then we could add all the I/O. And adding the I/O using Spring is very simple. For example, this is a film controller, which is, well, controller from MVC. And these are the methods. That's it. It's got the facade. It can get films or get single film, right? And if you want the database, the real database, for example, MongoDB or H2 or PostgreSQL, then you got to have an interface. And that's pretty much it. Spring will generate everything for you. Then we need a configuration, and we already had a configuration because for tests, we needed film configuration with a film facade. And this was the method that we were calling, right? So have a look at this. Now I need to this also working in production, not only tests. So what I need? I need another method which has a notation bean that Spring will understand and actually fire up as the real implementation of production or integration tests. And I'll need to inject the I/O only. So I can make this method called that one with in-memory film repository. And that's pretty much it. And I now can write the integration test or acceptance tests. And some people say, okay, but this part will actually be used only in the tests. Does it make sense to have some code in your production code that is only being used in the test? Well, my answer is, you can also have it working in, for example, production. Why would you need a database in memory in production? Well, for example, because you're waiting for the real database and you have to show the demo. Or maybe because you are on a train and you want to see how the application looks like on a train, and then you don't have the database, for example. This could work as well. And a colleague of mine actually decided that the profile that you should use for this, because in Spring you use profile just to have several configurations that can run sometimes at the same time, sometimes on different times. It's called Alzheimer, because you forget everything after the application is restarted. So how about using mocks and stubs, things that are very popular? Have a look at this. What will happen if the article facade, the method inside the configuration class, will have all those dependencies, and we will use this method in tests? What happens is that we make available article repository, for example, because we can use mocks and stubs in tests, right? Now, what happens is that because the user of that method, which is a developer, perhaps another developer, perhaps you, will have to actually create in-memory article repository inside the test, then he will use that article repository to verify whether the data that he wanted is inside the database, right? And that's not exactly what I want. I want the developer to treat the module as a black box, to run against it and test the behaviors. This is the base of behavior-driven development. So what I do is I actually inject only, for the test method, I inject only other modules, dependencies to other modules. This looks like this. My article module actually has got to inform promoted article module whenever I delete an article, because it's no longer promoted. And the reader module, which is the query part from the CQRS on an architectural level, and that some article was published. So what happens is that in a test, I actually have this. I call new article configuration, article facade, and I give, in this method, I have only 2 mocks. And those mocks are actually methods, are actually other modules. And I could go further, because I could go into events and have basically no mocks whatsoever, because all those modules would be independent based on just throwing an event and reacting on event. But that's a different story. This is this is simpler. So this actually promotes testing the behavior instead of internal state. And this makes the module not brittle and your test not brittle, because you have to test the behavior. You only have to test, you can only touch the external API of a module. And we will have to skip the sub-packages, because the lady there is making me nervous. And yeah. So the summary here is this. If you can, we now have Java 9, right? We have modules inside of Java. And the question is, are they going to be used the way we used jars for stuff that has several thousand lines of code? Or are they going to be used as we use packages, for example? And I don't think they're going to be used as packages just because it's not convenient enough. And because we have packages, why not use them? So if you create mid-sized building blocks, something between hundreds and thousands, as a package scope, then you have modules right away in your architecture. And another thing I forgot to mention is actually, quite often, we take those modules and remove them to another microservice, because they tend to grow, right? And the cool thing about it is that if a module has got a facade, just an entry point, and it's all package scope, the tests are all ready for the whole module, and taking it out is pretty simple. So think about the public world as a published interface from now on. Try to do this, and you'll see how better your code will be. If you can, remove the public from all the templates in your IDE, okay? If you create a new class in IntelliJ IDEA, you will have it as a public default. It makes no sense. Then test those modules as black boxes. Test them by interacting with them through the public interface that you have, so the public classes, and don't touch the internal stuff. And you will have behavior-driven development for free. You don't have to buy my trainings, for example. much cheaper. And write acceptance tests as unit tests, okay? You can have 90% of the application, basically everything except for testing the I/O parts, tested very well, very fast, in milliseconds, okay? Or in the worst case scenario, in a second or two, by just using this approach of hexagonal architecture. Then write integration tests to check the wiring, I/O configuration, and the whole positive flow, but only the positive flow. Why? Because if you wanted to test all the corner cases, first of all, you have them covered probably already inside your unit tests. And the second thing is that, well, it's slow. Why would we want to have tests that run slow? And this is actually simpler than not doing it, okay? Because I do not have to add a public keyword to every single class. I do not have to think about which package should this class be in, right? It's simple. This is my module. This is my package. This is my class. It's being used here. It's local. Let's make it package scope, and it's over. And this way, you will build modules that are easy to understand and reason about. Thank you.
Thank you very much for your presentation. Anybody have questions?
Okay, thank you for the presentation, and I have two questions. First one is about your approach of testing. You implement a hash map or some structure to test the modules, and there's another approach to use already implemented embedded database in memory in Java. So your benefit of your approach is it's faster or it is isolated?
Okay, I use in-memory databases already. I have Fongo instead of Mongo. And it's still, I need to have, in any kind of integration test there, I need to start my Spring. And Spring takes 22 seconds. So if I was supposed to make test-driven development waiting 22 seconds for every test, no way.
So it's just faster.
So it's about speed, right?
Yeah, it's about speed.
You can use, because actually using Fongo or using a physical database in a file does not make much difference in terms of speed, because in one case you have to start the database even in the memory, and the other you have to connect to the database, right? The other approach is just to have it in process and in memory, which is just what I've shown.
It's
right?
actually, as I am asking about. And another question about Spring Boot, as I understand you use it on production, yeah?
Yeah.
You know, in Spring Boot, I tried, it's quite cool, but it's a lot of auto configuration, and somebody said that we're afraid to use it on production because so many magic inside. What is your feeling? Probably you get some traps and tricks about it. Or how do you think? Is it okay to use it?
Once again?
About Spring Boot. Your feeling about using it on production, because...
So, yeah, I'm using Spring since 2007. Not Spring Boot, because Spring Boot wasn't there yet. And I'm using Spring Boot since the version 0.6. And to be honest, I love it. And it's not complex. It's very easy, actually. So, of course, you can write it on from hand, right? But you don't need it. My application is just pure Java code. All the stuff that Spring Boot does is the stuff that I don't want to do because it's boring. Like create SQLs or set up connection to the database. I don't want to do it, and it does it, right? So with every framework, you have to actually, there is the trade-off. You either learn the framework or it's all magic, right? Yeah. So you cannot choose too many frameworks because you will have to learn everything or everything will be magic. But I suggest that Spring and Spring Boot is the most popular framework right now in Java, and it's definitely worth actually learning it, okay?
Okay, thank you.
Okay, thank you. Next one.
Thank you very much for your presentation. And as I learned, we were talking about the middle size applications. Can we interpolate this approach or somehow apply it to big applications where numerous flows and they interact with each other closely and much? Thank you.
So basically every single big application is a set of small applications that is intertwined together, unfortunately, right? So microservice system as a whole is just one large application, but distributed into small modules that work all around the place. So my question is, do you want to know how to deal with the large existing legacy application, or how you want to do it with modules going into microservices?
The question was whether we can apply this as-is approach.
Yeah. I tune those packages quite often into different microservices, right? So
but I think in this case, this will be separate threads that minimally communicate with each other, and in this case, I think we introduce copy-paste technique.
Of course, that's why I gave you these links, okay? Take a look at them, because what they show is actually how to get from a single application, which is a monolithic application. This is just an example, but it's a very nice example, by using different approach into actually a modular system inside a single jar, and then to move it into microservices, and how to deal with the communication part, because that's the difficult part, of course. If we had events, and if you use events for that in Spring, then it's pretty simple, because you have no dependencies there. Just somehow you need to get those events and be able to throw an event somewhere in the event bus, whatever else. If you have just a normal communication like calling a controller, it's a bit more tricky, but it's not that bad. So take a look at this. I will post it on Twitter. This is all public, by the way. You can go to this URL. Does it work? Yeah. So you can go basically here, make a photo, or just follow me on Twitter, and the links are there, okay?
Okay, anyone have still a question? Okay, so thank you very much. Big applause.